Okay, so let us start now our meeting. So let me just share my screen. All right. So yesterday, I gave you a quiz, right? Ah, yeah, correct. Yesterday, correct. So I gave this
Yes.
one as your quiz. Now, seems that I saw that most of you answered 0/0, which is indeterminate, correct?
Yes.
Again, I mentioned that you have to find ways, without changing the value, okay, of our original equation, okay, find a way to cancel maybe or to expand or to factor out, not to make the final answer 0. Okay? So today, I will show to you the answers or the solution. Okay? So here are the solution for the 1, 2, 3, 4, and then 5. So this is the first one. So what we can do is we can actually expand, not really expand, we can factor out this one. Okay, we can factor out the 2x squared minus 17z plus 8 into 2z minus 1 minus 8. Okay, so same thing here. We can tweak this one into something like this. We multiply it to negative so that, we have z and then minus 8 the same in our numerator. Okay, so why we did this one? We did this one so that we could cancel out the z minus 8. So notice that when we cancel out z minus 8, so retaining the 2z minus 1 over negative 1, that would give us a result of negative 15 if we substitute a to our z. So the limit of 2z squared negative 17z plus 8 over 8 minus z as it approaches 8 is negative 15. Okay? So did you guys get the idea so far on how did we get 15?
Yes.
So again, we factor out this one, okay? You can prove it that, this once you multiply this one to each other, you will get this one. Okay, for denominator, we need to multiply negative sign, okay? Negative times z is negative z, negative times negative 8 is positive 8. So we're not changing the value of the equation. We're just trying to tweak it, okay? Tweak means like, change, but uh, not really change. Like do something, okay? Do something uh, to change the format, something like that. Okay, so with that, we'll be able to cancel this one. And then retaining 2z minus 1 over negative 1, this will give us 15. Now for the second one, okay, for the second one, as you can see, we can still factor this one out. Okay, into y minus 7 times y plus 3. While the denominator, we can factor out this one into 3y plus 4 times y minus 7. Okay? So you can test this one if you want, of course. You can multiply this one to each other and you will get this one. You can multiply this one to each other and then you will get this one. Okay? So unfortunately, when it comes to factorization, there's really no pattern. Well, maybe there is once you have experienced that kind of problem. So that is why in my or in our EngMat a while ago, factorization needs practice. Okay, you really need to practice a lot for you to be able to know how do I factor out this one? How do I make this equation into something like this? Okay, so you need a lot of practice. Okay, so as you can see, once we already have this kind of format, we can cancel out y minus 7, retaining y plus 3 and then 3y plus 4. And then substituting the 7 to our y, okay, that would give us 10 over 25 or 2 over 5. Okay? So did you guys get the idea so far?
Yes.
Okay, very good. So again, in limits, indeterminate is not a valid answer. That is not a good answer to be exact. Well, if you cannot find, of course, if you cannot find any other way, then of course the answer to that problem is indeterminate. But like this, if we can find ways, to cancel out this one and this one, and then will give us a result that is not zero or not that is not indeterminate, then that is the correct answer. Okay, then better if you will do that one. Okay? All right. So let's proceed to the number 3. Let me just set this one aside here. Okay. So number 3, this one I was actually hoping that someone will get this one. Okay. It's just a matter of, expanding this one. So 6 plus h times 6 plus h will give us 36 plus 12h plus h squared. Okay. Just expand that one. 6 plus h. Okay, 6 times 6 is 36. 6 times h is 6h. H times 6 is another 6h. So just add those two. That will give us 12h. H times h is h squared. And then minus 36 over h. And, just simplify this one further by, of course, removing the 36, retaining the 12h plus h squared. You can still factor this one out. We can factor out h. So resulting into h times 12 plus h over h. And as you can see, we can cancel out h and then retaining the 12 plus h. So 12 plus 0 is simply 12. Okay? So are we clear in number 3?
Yes.
What about the others? Why is that only Muhammad Ibrahim is the one that is answering? What about the Agdag? When see the Agdag? Ah, yeah, I forgot. I forgot. I need to check your attendance. Okay. Let me just erase. Yes, let me just reply to this one. Okay. Let me just check your attendance. One. Okay. Abdul Hussein, are you present? Abdul Hussein, present. Adolay, Yosef. Adolay, are you present? Okay, maybe absent. Adriano, Sherlyn.
Abdul Hussein. Yeah,
Abdul Hussein, you're there?
yeah, yeah.
Okay. Adriano, Sherlyn, absent. What about Alhamed? Alhamed Mohammed Abubakar.
Present, sir.
Okay. Al-Kulaifi Nasser Mohammed Saleh.
I am here, teacher.
Okay. Al-Kulaifi Zayed.
I am here, teacher.
Okay. Alafris Wadagan Ronnie. Alafris. Absent. Alberto Christian J. Absent. Atiwag. Absent. Bagawe. Absent as well. Pantasha.
Here,
Pantasha.
Benta. Here.
You're there? Okay. Bena. Bena is absent. Bernal.
Yes, sir. Present, sir.
This Pinrich, Jazen, Bena. Bena, okay. Bena is present. Bernal is also present, right?
Yes, sir.
Okay. Bernardino.
Present, sir.
Okay. Binggit. Binggit. Absent. Binolok.
Present, sir.
Okay. Bokari. Bokari. Absent. Uslig. Okay. Kalahi.
Present, sir.
Kanas.
Present, sir.
Daagdag.
Sir, present.
Daos.
Sir, present.
Okay. Delizo.
Present, sir. Adulay.
Padlala. Padlala.
Present, sir.
Sir. Okay. Felipe.
Present, sir.
Feriol. Feriol. Absent. Festejo. Festejo. Absent. Gana. Gana. Absent. Gom-gom o. Absent. Purboda. Absent. Ibrahim. Mohammed. Absent.
Present.
Okay. Las Egan. Las Egan. Absent. Lee Jamie. Absent. Lonogan. Absent.
Sir, present.
Okay. Lonogan is present. Muhammad. Muhammad. Muhammad Hassan Muhammad Ali.
I'm here, sir.
Okay. Madi.
Present, sir.
Okay. Mang Usan. Mang Usan.
Present.
Okay. Mohammed. Mohammed Magdi. Mohammed Kaira. Mohammed Kaira. Mohammed. Absent. Mohammed Hegazi. Omar Ahmad.
I'm here, sir. Magdi.
Present, present.
Magdi. This is you, Magdi, right? Mohammed
Yeah,
Magdi.
yes, my.
Okay.
Sir, present. Adulay. Joseph.
Abdullah Yosef. This is here. Okay. Mohammed Osama Ahmed Saleh. Absent. Morales.
Present, sir.
Morales Justin.
Present, sir.
So we have two Morales. Okay. Other one is Vincent. The other one is James. Okay. Oredina.
Present.
Okay, Pascual. Pascual? Present. Ah, we have two Pascual. Pascual Renzo and then Pascual Diomel. Ah, no, no, no. Pascual Diomel and then Pascual Norin. Norin. Absent. And then Tamiing. Absent as well. Okay. Tamiing, Norin, Diomel, Mohamed Saleh, Jamie, Tyron, Urboda, Gomgom O, Gana, Feriol, Bukhari, Binggit, Pagawe, Atiwag, Alberto Alafris, and Adriana. Okay, so they are still not around. Okay, let us continue now our discussion in your quiz number 1. Okay, so for the number 3, are we clear so far?
Yes, sir.
Yes, sir.
Okay, let's proceed to number 4. So in this example, in this number or item, what we can do is we can multiply 3 plus square root of x plus 9 over 3 plus square root of x plus 9. Okay, again, we are not changing the value since this 1 is still 1. Okay, it's like multiplying 1. Okay. So in here, we just multiply this to side by side. Okay, we will have this one now. And then in here, as you can see, it's like, it's like a new equation, but it's not. We just simply multiplied it and then simplified it. So to show to you, we have here 3 minus, okay, yes, we have to use a snipping tool. Make it faster. That we are not. Okay, I'll just write everything. So 3 minus the square root of x plus 9 times 3 plus square root of x plus 9. Okay, so we just distribute. Okay, so 3 times 3 is equal to 9. 3 times this 1 is 3 square root of x plus 9. Okay, seems like it's too far. So this one is plus 3 square root of x plus 9. Okay, next is negative square root of x plus 9 times 3. So that is minus 3 square root of x plus 9. And for the last one, negative square root of x plus 9 times positive x square root of x plus 9. That would give us negative square root of x plus 9. Since they are just the same, we can make this one squared. Okay? And then as you can see, we can cancel out this one, this plus 3 square root of x plus 9, since this will become a 0. Okay, and this one, we can cancel out the square root. Okay, so squaring the square root will just cancel, retaining whatever is inside. So this is equal to 9 minus x plus 9. Okay, which is now the same with our denominator in here. Correct? So were you guys able to follow? So let me know if you weren't able to understand you know, any part of this one. So we can explain and then go back.
Understood.
So next one is that we distribute, okay, the negative to our parentheses. Okay, so this will become 9 minus x minus 9. Correct? Afterwards, okay, we cancel out this one since 9 minus 9 is just 0. Retaining the negative x, which is now this one. So numerator is still the same as it is, but the denominator now became negative x. And next is we can, okay, let me just see what happened next. So we just simply cancel out the x, okay? Cancel out the x, okay, which is now equal to negative 1, and then retaining the 3 plus the square root of x plus 9, which is this one. Okay? Then afterwards, we can now substitute 0. So this will become 0 plus 9. Okay? So square root of 9 is 3, since this one is already 0. Okay? So 3 plus 3 is 6. Over negative 1 is just simply negative 6. Okay? So were you guys able to get the process on how did we get negative 6?
Yes, sir.
Yes, yes.
Okay, very good. Again, there is no pattern. It's all about your critical thinking. Okay, it's how you imagine things. Okay, just widen your imagination so that you could cancel out. You could uh tweak the format wherein it will not result into indeterminate. Okay, so let's proceed to the last item, which is this one, number 5. Supposedly this one is 8 items, but I made that one 5 so that you guys will have more time. Okay, anyway, we have this original equation, and what we can do is we can multiply the numerator, okay, to the numerator and then denominator. Okay, again, this one is just simply 1 if you will cancel that one out. Okay, so just multiply, okay, just like what we did a while ago. And then you will get 2x plus 22 minus 16. Okay, so I will not show the process anymore. It's similar to the number 4, like what we did in here, multiplying this to each other. Okay, so you can multiply this one to each other, and then you will get this one as the simplified version. Okay. Now, for this one, we now have 2x plus 22 minus 16 over x plus 3 over square root of 2x plus 22 plus 4. So next thing is that we can factor out this one by, okay, let me see, by 2. Is it by 2? It's 2x plus, yeah, okay. So I forgot. So 22 minus 16, it's just simply 6. So factoring 2 to the 2x plus 6 is 2 times x plus 3. Okay? And then as you can see, we can cancel out x plus 3 in our numerator and then in our denominator. So retaining the 2 over square root of 2x plus 22 plus 4. And afterwards, we can try maybe, substituting the negative 3 to our x. And as you can see, that would give us 2 over 8, or just simply 1/4. Okay, for the number 5. So did you guys get the idea so far?
Yes, yes.
Yes, sir.
Okay, so don't be shy to ask. So please let me know the others who cannot follow or who weren't able to follow the solution. So I will explain it to you from that point. Okay, so if you don't have any other questions anymore, we can proceed now to the next module. Okay, so this module was came from Ingegneriere. Okay, so I will adapt some, okay, just some. Since we are already done with limits, okay, we will not discuss this one anymore. The definition of limits and then formula in maths. So well, of course you can review some of the examples. It's okay. Okay, notation of limit, sum rule, extended sum rule, the constant function rule. So we already discussed that one. You know the rules under the limits. Okay. So some examples, more examples, and then just a summary of a function. Okay, so in here, we will now start with the special rules or the special formulas under the derivation or derivatives. Okay, so in here, we have the first one, the derivative of a constant. Okay, the derivative of a constant, for example, y is equal to 5. Okay, once you derive this one, this will give you 0. So any constant, okay, any constant, once you derive it, it's always equal to 0. Could be 100, could be 1/4, 0.25, 1 million, 10 million, it's always equal to 0. Okay? Second one that you need to memorize is the derivative of a variable. Any variable could be derivative of x, derivative of y. Okay, so that would always give you 1. Okay, like for example, the derivative of x is 1, derivative of y is 1, derivative of z is 1. Okay, for as long as it's just a variable. Now, if it's a combination of a constant and variable, so it's constant times variable. Okay, like for example, negative 2x. So we have the constant negative 2 and then we have the variable x. So if we are going to derive this one, this will give us negative 2. Okay, so another example is if it's y is equal to then 10y. It's not possible. If this is y, the other one should be x. Okay, because it's in dy dx, change of y over change of x. Okay, so this one is equals to positive 10. Okay, so in constant times variable, it's like removing, okay, the variable. Okay, can you guys follow so far for the first three derivation rule?
Yes, sir.
Okay. Now the other one is it's still a constant and then a variable, but with an exponent. Okay. Like for example, this one. So this one has a constant of 1. Okay. This one has a constant of 1. Okay, by default. Okay, and then this one has an exponent of 3. Okay, so if we are going to derive this one, so just bring down, okay, bring down the n. Okay, so from the exponent we bring down the n, and then deduct 1. Okay, or minus 1 to our exponent. Okay, so here we bring down the 3, which is now this 1. And then afterwards, we reduce 1 or we deduct 1 to our exponent. So it's now 3 minus 1. So of course, simplifying this one, this will give us 3x raised to 2 or 3x squared. Okay? So are we clear?
Yes, sir.
Okay. So this one is the same with the first one. Again, it's just that it's emphasizing that we now have a constant number in here. So this one now is not 1 anymore. Okay, it could be 2 onwards, or it could be -1 or -2 or -3. Okay, the same thing. We bring down the 3. Okay, so from here we bring down the 3. Okay, we still retain the 2. Okay, and then we deduct 1 to our exponent. Okay, 3 minus 1 is this one. Then afterwards, to simplify this one, since we already have an existing constant, so just multiply it to the bring down exponent. So 2 times 3 is 6. And then 3 minus 1 for the exponent is 2. So it's x squared. So 6x squared. Okay? Clear?
Yes, sir.
Okay. So the last one, is this the last one? Let me check. Not yet. Okay, we still have a lot more. Okay, so let me just erase. So the derivative of two or more terms or function, like for example, derivative of f of x plus the derivative of g of x minus the derivative of q of x. So we can actually distribute the d for each expression. Okay, so it's now like the derivative of f of x plus the derivative of g of x minus the derivative of q of x. Okay, so we call this one like differentiation by terms or by parts. Okay, so this is an example of constant variable exponent, which is this one, constant variable exponent. The second one is an example of a variable exponent. Okay, which is the one that we had at the top. It's one variable and then exponent only. And then the last one is constant and then variable. And then the last one is just a constant. Okay, so we will continue this one later on since we don't have much time anymore. Okay, so just wait for my second announcement for the part 2. Okay.